Good evening, all of you. My name is Abhishek Rawat. Today, my demo topic will be gaseous state. So, as we all know, student, gaseous state comes in the chemistry chapter. So, first of all, I will discuss about what is chemistry. So, chemistry is a study of matter, and as we all know, matter has been classified into two types, that is physical classification and chemical classification. If I talk about the physical classification of matter, matter has been divided into six types, that is solid, liquid, gas, plasma, Bose-Einstein condensate and Fermi condensate. These are the six types of matter. Among these six types, if I talk about the first three, that is solid, liquid, gas, the liquid state and the gaseous state we studied in class 11th, and the solid state we studied in class 12th. So the liquid state and the gaseous state we studied in 11th, and the solid state we studied in 12th. So if I specifically talk about what is gaseous states, it is a kind of state of matter wherein the intermolecular forces of attraction are weak as compared to solid and liquid. So here the intermolecular force of attraction are weak. So they have weak IMF, that is intermolecular forces of attraction, as compared to solid and liquid. The second thing which govern the state is the thermal energy. In case of gases, thermal energy is more than the intermolecular forces of attraction, that is thermal energy is more than intermolecular forces of attraction. Now one question can come to our mind, that what is the thermal energy? So thermal energy is that energy which is possessed by the molecules of the matter at a certain temperature, and that temperature should be greater than the absolute zero temperature. If we have any temperature value which is greater than the absolute zero temperature, the molecules of the matter will be vibrating and hence they will go far from each other. So if we have very small temperature also, these molecules will be far from each other, and the intermolecular forces of attraction are also acting simultaneously. And in case of gases, this thermal energy overcomes the intermolecular forces of attraction, and hence the molecules of the gases are far from each other. Now if I talk about the gaseous state itself, we have two kind of gases. So the gases also are of two types, that is first gas is called as ideal gas, and the second gas is called as real gas. So first gas is ideal gas and the second gas is real gas. Now the question may come to our mind, what is ideal gas or what is real gas? So if I talk about ideal gas is that gas in which the intermolecular forces of attraction are zero. Herein the intermolecular forces of attraction is zero. Means between the molecules of the gas, in case of ideal gas, there is no intermolecular forces of attraction. In reality, there is no such gas as an ideal gas. It is a hypothetical gas. We consider this gas for studying the various laws in the gas state. In reality, we have the real gas. Now the question may come to our mind, what is in real gas? The real gas is that gas which has intermolecular forces of attraction, or I can say wherein the intermolecular forces of attraction are not zero, right? So this is about the two gases that we have, that is ideal gas and a real gas. Now if we go more deeper, that is how can I define the condition of a gas, or how can I define the state of the gas? So the condition of a gas or a state of a gas can be defined by four parameters, that is the condition of a gas slash the state of a gas can be defined by four parameters, that is pressure, volume and Nt. What is PV and T? PV and T stands for pressure of the gas. So if I have to define these four parameters which define the state of the gas, that is the four parameters which define the state of gas is P, V, N and T. What is P? P is for the pressure of the gas. Pressure of a gas. What is V? V is volume of gas. volume of gas. What is N? N is number of moles of gas. Number of moles of gas. What is T? T is temperature of gas. T is temperature of gas. So these are the four parameters which we take to define the state of a particular gas. That is pressure, V for volume, N for number of mole, and T for temperature. So what is P for pressure? So pressure of a gas is nothing, as we know, at a particular temperature, the molecules of the gas are continuously vibrating. So when a gas is present in a container, for example, suppose we are taking a gas in a container, so continuously the molecules of the gas are vibrating and colliding to the wall of the container, or they are colliding with the wall of the container. When they collide with the wall of the container, what happens? They exert a certain force on the walls of the container, and this force per unit area for all the molecules of the gases constitute the pressure of the gas. So what is pressure of gas? It is the force exerted by the molecules of the gas, on the walls of container, So the walls of container, the force exerted by the molecules of the gas on the walls of container per unit area is called pressure. Pressure of gas. Now if I talk about the different units of pressure, that is units of pressure can be the most commonly used unit for pressure is atm. That is atm. It can be Newton per meter square. It can be Pascal. It can be bar. It can be torr. It can be mm of Hg. These are the different possible units of the pressure which we have. If I talk about the next thing, that is second, that is volume of gas. So volume of gas is nothing but the volume of the container where we are taking the gas, because whenever we talk about gas, we talk about a particular container where we will be keeping that gas. So if suppose you are keeping in the room where you are living right now, where you are seeing this one, so whatever is the volume of that container where the gas is kept, that is the volume of the gas itself. The reason being that the gas molecule, when they are kept in a container, they occupy the whole container, and hence the volume of the gas is the volume of container itself. So what is volume? Volume of gas is volume of container itself. Volume of container itself. And what is this volume? The units of this volume will be centimeter cube, it can be liter, it can be meter cube, it can be mm cube, it can be dm cube, and it can have any units of length to the power 3, or it can have unit as liter also. So these are the different units of volume of the gas. Next parameter which we are having is N, that is number of moles. So N also called as number of mole. What is number of moles of gas? So number of moles of gas tells us about how much gas molecules we are having. So number of moles tells us about how many molecules of gas we are having. For example, we have 10 gram of a gas. We have 10 gram of, I can say, O2 gas. Means how much oxygen gas molecules I am having, I can come to know using this thing. How? I know that the molecular mass, or I can say the molecular weight of O2 is 16 into 2, which is equal to 32 gram per mole. Means per mole how much oxygen is there? 32. So how many moles of oxygen we are having? So moles of oxygen, we know that we have three formula for the moles of gas. So moles is defined as given weight divided by molecular weight, which is equals to volume of solution in liter divided by 22.4 liter, which is also equals to what? Which is also equals to the number of molecules of gas, divided by the Avogadro number, right? These are the three different formulas for the number of moles of gas, and this second formula is valid at NTP condition, that is normal temperature and pressure, and sometimes it is also valid at STP condition. So it can be valid at STP or NTP condition, right? So through this we can determine how many moles of oxygen gas we are having. We can simply be calculated by 10 gram divided by 32 gram per mole. So mole will cancel mole, it will be 5 upon 16 mole, right? 2 5s are 10 and 2 6, that is 6. So 5 upon 16 mole, or from this mole we can calculate the number of molecules also. From this mole we can calculate the number of moles also. So this is how we can know about the state of the gas. The last parameter which helps us in determining the state of the gas is temperature, that is temperature. So what is temperature? If I have to say, you have to say temperature. Basically temperature is defined as the degree of hotness or the degree of coldness of a gas. So what is temperature? It's the degree of hotness or degree of coldness of a gas. Its units are, most fundamentally used units for the temperature are Kelvin in a Kelvin scale, Celsius in degree Celsius scale. It can be Fahrenheit. It can be etc. Means in other school also we do have the different units for the temperature. And if I have to tell the relation between these units, the units are C upon 5 is equals to K minus 273 upon 5 is equals to F minus 32 upon 9. So this relation I can use to convert the temperature in degree Celsius scale into the temperature into Kelvin scale into the temperature in degree Fahrenheit scale. This is a relation which we need to use, and we need to remember this relation, right? So these are the 4 parameters which are used to define the state of the gas, right? Thank you everyone. That's all from today from this demo. Thank you.